pi molecular orbital diagram of 1,3-butadiene. Butadiene, the name itself indicates buta means 4 carbon atoms, ene means double bond, diene means 2 double bonds. So, 4 carbon atoms containing 2 double bonds. C1, C2, C3 and C4. These are 4 carbon atoms. These 2 are double bonds. That 2 double bonds are in alternate positions. So, butadiene is a conjugated diene. In butadiene, the carbon is in sp2 hybridized state. Each carbon is in sp2 hybridized state. We know that the carbon atomic number is 6. In ground state, the electronic configuration is 1s2, 2s2, 2p2. Excited state electronic configuration is 1s2, 2s1, 2p3. One electron is excited to p level. So, sp2 hybridization means one s orbital and two p orbitals combined together. It forms three sp2 hybrid orbitals. So, s orbital and two p orbitals combines together three sp2 hybrid orbitals, and now each carbon containing one unhybridized pz orbital. Here we can see the diagram. The red color lobes are hybrid orbital, 3 sp2 orbitals. So, 3 red color lobes is there. And black color lobe indicates unhybridized p orbital. So, p orbital is in black color and sp2 hybrid orbitals are indicates in pink color. So, here this diagram indicates the unhybridized p orbital. 4 in butadiene, 4 carbons, 4 p orbitals are there. So, sp2 hybrid orbital, 3 sp2 hybrid orbitals. So, in butadiene, there are 3 CC sigma bonds and CH sigma bonds are 6. 1, 2, 3, 4, 5, 6. 6 CH sigma bonds and 3 CC sigma bonds. All these 6 sigma bonds and CC sigma bonds are formed by overlapping of sp2 hybrid orbitals. So we know that sp2 hybrid orbitals always form sigma bonds. Hybrid orbitals form sigma bonds. Now, coming to the point, the p orbitals forms the sidewise overlapping. That's why the bond is pi bond. So, the unhybridized p orbitals are overlapped. It forms pi bond. So, 4 p orbitals are there. Every p orbital having 1 electron. So, 4 p orbitals containing 4 electrons. These orbitals involved in bond formation. Which type of bond? Pi bond. Hybrid orbital forms sigma bond. Unhybrid p orbital forms pi bond. So, that's why the title is pi bond formation of 1,3-butadiene. Now, according to molecular orbital theory, the number of molecular orbitals formed is equal to the number of atomic orbitals contributed. I mean overlapped. Here 4 in butadiene, 4 atomic orbitals, I mean 4 p orbitals are there. 4 p orbitals are overlapped. So 4 molecular orbitals are formed. 4 atomic orbitals overlapped forms 4 molecular orbitals. Half are bonding, half are anti-bonding. It means 2 are out of 4, 2 are bonding orbitals and 2 are anti-bonding molecular orbitals. The orbitals are represented with pi 1, pi 2, pi 3 star and pi 4 star. Here pi 1, pi 2 are bonding molecular orbitals. Pi 3 and pi 4 star represents the anti-bonding orbitals. So pi 1, pi 2 are lower energy orbitals. Pi 3 and pi 4 are having high energy. We know that lower energy orbitals filled first. That's why pi 1, pi 2 are called as occupied molecular orbitals. So electrons occupied first here. That's why these are occupied molecular orbitals. So highest occupied molecular orbital, it is HOMO. Pi 3 star and pi 4 stars are anti-bonding orbitals having high energy. So these are unoccupied molecular orbitals. That's why it's called as LUMO. HOMO and LUMO. Pi 1, pi 2 are HOMO and pi 3 star and pi 4 stars are LUMO orbitals. Here we can see the molecular orbital diagram of 1,3-butadiene. This is energy axis, E for energy, and 4 carbons, 1, 2, 3, 4 carbons, and these are p orbitals. Black color indicates p orbitals. Now, the plus sign here, there, plus and minus signs are there. All these are signs, not the charges. The bonding interactions are happening between the lobes having same sign. Same sign. The bonding interactions happens between the orbitals of same sign. The orbitals of same sign overlaps are bonding interactions. Orbitals of different signs are anti-bonding interactions. Okay. Now coming to the diagram. These are energy axis E and 4 orbitals, pi 1, pi 2, pi 3 and pi 4. These two are bonding, these two are anti-bonding as I expressed previously. Now, in first level, this is the first level, pi 1 orbital, there is no nodal planes. There is nodal planes. In the second level, that pi 2, here one nodal plane is there. In the third level, there are 2 nodal planes are there. In the fourth level, energy level, there are 3 nodal planes. It means at each increase of successive level of energy, nodal planes are increases. So here this in the starting there is no nodal planes. So energy increases, the nodal planes are increases one by one. So here one nodal plane, next level 2 nodal planes, next level 3 nodal planes. Okay. So for each increase of successive energy level, the nodal planes are increases each one. So 0, 1, 2, 0, 1, 2, 3 are nodal planes. Right. Coming to the pi 1 level, there is no nodal planes. All are bonding interactions. So I put plus sign in the above the lobes. All are bonding interactions. So bonding interactions between C1, C2, C2, C3, C3, C4. So there are bonding interactions are 3, nodal planes are 0. Here all are bonding interactions, it represents with the sign plus. Plus bonding interaction, plus bonding interaction. Here, okay. Now, coming to the pi 2 level, pi 2 bonding orbital. In pi 2 bonding orbital, the energy is increases. So, the energy is increases then compared to pi 1. Energy is more than compared to pi 1. So, if energy increases, the nodal planes are increases. That's why one nodal plane, it is put in the center. So, this is nodal plane. The nodal plane is in between C2 and C3. So there is no bonding interactions. That's why plus and minus is put. These are no bonding interactions. Anti-bonding interactions. That's why plus and minus are anti-bonding interactions. Here C1, C2, there are 2 signs are same. The lobes having same signs. So these 2 are bonding interactions. 3, 4, C3, C4 also having same bonding interactions, same sign. So these 2 are also bonding interactions. So minus, minus, it means the same sign. Same sign indicates bonding interactions. Opposite signs indicates anti-bonding interactions. So here in the pi 2 orbital, there are 2 bonding interactions and 1 anti-bonding interaction and 1 nodal plane, right? Now coming to the pi 3 star level, pi 3 star level, the energy is increases another level. That's why two nodal planes are there. Two nodal planes are placed in between C1 and C2 and C3 and C4. So the nodal planes are present. If nodal plane is present, then the two are anti-bonding interactions. That's why C1, C2 are anti-bonding interactions because here nodal plane is there. C3, C4 are anti-bonding interactions because here nodal plane is present. Here C2, C3 are bonding interactions because there is no nodal plane, and also here you can see these two signs are same. The minus, minus. These two are bonding interactions. Here plus and minus. These two are anti-bonding interactions. Plus so minus. These two are anti-bonding interactions. Got my point? Now, C1, C2 are anti-bonding interactions. C2, C3 are bonding interactions because same sign. C3, C4 are anti-bonding interactions. Right? Nodal planes are 2. Coming to the pi 4, all are anti-bonding interaction. There is no bonding interactions. That's why all lobes are same, not having same sign, the same side. So plus sign, minus sign, plus sign, minus sign, alternate position. There is no bonding interactions here. The anti-bonding interactions between C1, C2. So that's why put plus, minus. Here, plus, minus, plus, minus. There is no bonding interactions. That's why there is no same sign in the same side by side, right? This is the energy level diagram of 1,3-butadiene. The E for energy axis. 0, 1, 2, 3 are nodal plane number. Pi 1, pi 2, pi 3, pi 4 are molecular orbital representation. And these are orbitals. Orbitals means here 4 orbitals containing 4 electrons. So 4 electrons are distributed as distributed in pi 1 2 orbitals and pi 2 2 electrons. Pi 1 2 electrons and pi 2 2 electrons. 4 electrons are occupied pi 1 and pi 2. No electrons in pi 3 star and pi 4 star. So the anti-bonding orbitals are empty and the bonding orbitals are filled. So it is the highest occupied molecular orbital. Electrons are filled. Low energy orbital filled first. That's why this is a molecular occupied molecular orbital. These two are unoccupied orbitals. That's why it is called unoccupied molecular orbitals. In the examination, we can easily remember in this way, plus, plus, plus. All orbitals are same sign. So same sign indicates all are bonding interactions. So all are bonding interactions. So there is no nodal planes. Here in the C, one nodal plane is there. So where the nodal plane is there, the orbitals are different signs. Plus, minus. These two are bonding interactions. That's why plus, plus. These two are bonding interactions. So same sign. These two are bonding interactions. That's why minus, minus. If nodal plane is there, then the two are opposite signs. The two are opposite signs, bonding interaction. And if nodal plane is present, the two interactions are overlapping, are anti-bonding. Pi 1 molecular orbital diagram. Pi 1. So this is lower energy level. All are bonding interactions. Electrons are delocalized over all 4 nucleus. This is lower energy orbital represented with pi 1. It has 0 nodes. So bonding interactions are C1 in between C1, C2, C2, C3, C3, C4. So plus signs, same sign. Same sign indicates bonding interactions. This is pi 2 molecular orbital diagram of 1,3-butadiene. Here there are two bonding interactions, one anti-bonding interaction. It has energy slightly greater than pi 1, but not so. the number of nodes is increased by 1 at each successive level. That's why one nodal plane is there. That one nodal plane is present in the center. So where the nodal plane, the two lobes are with different signs. Where the nodal plane, the two lobes are having different signs. This is anti-bonding interaction between C2 and C3. Bonding interactions are C1 and C2. That's why bonding interactions with the same sign. C3, C4, bonding interactions, right? Nodal plane is 1. This is pi 3 star molecular orbital diagram of 1,3-butadiene. It is anti-bonding. Star indicates anti-bonding molecular orbital. The electrons, there are no electrons in this level. That's why it is called as empty orbital. Here two nodes are present. Two nodes are present in between C1 and C2 and C3 and C4. So bonding interaction is only possible at C2 and C3. That's why minus minus. So these are bonding interactions. Plus minus anti-bonding interactions. Anti-bonding is happening when nodal plane is there. Nodal plane, if nodal plane is present, these anti-bonding interactions between opposite signs. No nodal plane, bonding interactions with the same sign. Coming to the pi 4 star molecular orbital diagram of 1,3-butadiene, it is strongly anti-bonding, energy is high, and it is also vacant at the ground state. All are anti-bonding. There is no bonding interactions. So, nodal plane is there. Nodal plane is present C1 and C2, and C2 and C3, and C3 and C4. So, all signs are opposite signs, plus minus, plus minus. So, no same signs are same side because all are anti-bonding interactions. There is no bonding interactions. Right? Thank you.